Myself, Professor V.M. Patel, Associate Professor in Civil Engineering, Government Engineering College, Modasa. In the very first lecture of angular measurement, we have seen that introduction of the survey, why angular measurement is required, where angular measurement is to be taken. We know that when the area of survey is undulating and crowded with many detail, triangulation is not possible, and in that case we are going for the traversing. We have know that there are two types of traversing. One is open traverse and closed traverse. We have seen the importance also where we are using in a open traverse, where we are using in a closed traverse or open traverse. The different purpose where we are using. We know or we have learned that for angle measuring, what are the equipment which is used. The angle measuring, there are two ways by which we can measure the angle. Generally for the civil engineering, we are using the prismatic compass and we are using in the surveyor compass. In the prismatic compass also, they are measuring the angle with reference to certain reference line. So today our lecture is what is bearing, how we can take the angle, what is the W.C.B, that is whole circle bearing, what is the reduced bearing. So number one, we started with the bearing. So bearing of the line is a horizontal angle which it makes with the reference line, that is known as the meridian. Depending upon the meridian, there are four types of bearing. First of all, what is a meridian? Meridian is nothing but the reference line which we create. It is an imaginary line which we create, and with reference to that line we are taking a horizontal angle in a clockwise direction. Whenever we are carried out the survey, we don't know, there is no reference line, but magnetic compass, it will provide some reference line. Whenever a freely magnetic needle is to be suspended, one end of the needle will be pointed toward the north and one end is pointed toward the south. And if we are measuring with that reference line, or we can say it is a magnetic meridian, that line which indicates a freely suspended magnetic needle, it is a magnetic meridian. And if we make the angle with reference to that, it is called magnetic bearing. If we create even imaginary line which pointed toward the true north and true south, and if we are taking the angle with respect to that, it is called as a true bearing. There are four types of the bearing. One is called the magnetic bearing, second is called the true bearing, third is called a grid bearing, and fourth is called the arbitrary bearing. If we create a grid, and with reference to grid line, if we are measuring the horizontal angle of our survey line, that is called a grid bearing. And fourth one is the arbitrary bearing. What is arbitrary bearing? Any line joining, we reference a two pole or one side of the building, or any arbitrary line we assume, and we make a horizontal angle of our survey line with that reference line, it is called as a arbitrary bearing. Now next is, now see this figure. Now this is a true north line, is indicate the true north. This line will be indicate a magnetic north, and this is our line. This one downward is our original line of survey. If we are taking the angle with respect to this line, that is the magnetic north and magnetic south line, this angle, it is called as a magnetic bearing. And if we are measuring the true north angle with reference to the true north, that means that this angle, then it is called as a true bearing. It is called as a true bearing. And difference between true north and magnetic north, originally, as per the theory, these two things would be the same. But in actual, there are a certain angle. It is a very small angle. It may be the 1 degree or less than 1 degree. But this is called as the magnetic declination. This is called as a magnetic declination. Here, you will clearly understand from the point A, this is the true north, this is the magnetic north. Angle alpha, that is called the true bearing of B from A and from beta, that is the magnetic bearing of B from A. So this is the horizontal angle which we are doing with reference to magnetic bearing. Now bearing are designated in the following two systems. Bearing we are designated, one is known as the whole circle bearing system. In short, we call as a W.C.B. And the second one is known as the quadrantal bearing system, that is the Q.B. Now, what is a whole circle bearing system? Now, bearing of the line measurement with reference to the magnetic meridian in the clockwise direction is called magnetic bearing, and its value varies from 0 to 360. Always measure the angle in a clockwise direction. This is must on both the system. In a quadrilateral system, the start angle of measurement will be start from the north and progress in the clockwise direction. There are 4 quadrants. The whole 360, it is divided into the 4 part. From 0 to 90 degree we call as a first quadrant. From 90 to 180 degree we call as a second quadrant. From 180 degree to 270, that is called as a third quadrant. And from 270 to 360, it is called as a fourth quadrant. And here it will the whole figure. This is north, south, east and west. The whole process. In the whole circle bearing, we are taking the reading with reference to north only. Angle may be any one. Suppose the line A. Then we measure the angle from north to this. This alpha indicate the whole circle bearing. Suppose our line is B. That is, then we are taking the reading from here to here. This angle is called the whole circle bearing. Suppose our line is C. Then for the whole circle bearing, we are taking the reading from here to here. And suppose it is a D, then we are taking the from this to this whole. That is called the whole circle bearing. But in a quadrilateral bearing, it is divided into the 4 parts. This is known as the first quadrant. We can say it is a north and east. This is the second quadrant, we call as a southeast. This is the third quadrant, we call as a southwest. And this is the fourth, we call as a northwest. We are measuring angle with respect to north or the south, whichever is nearer. Whichever is nearer. We will learn a detail. Suppose the line A, then we measure the angle from this angle only. This is a quadrilateral bearing, and here we are mentioning the direction north, then angle and east. North, whatever the, suppose it is a 30 degree, then the north 30 degree east. Suppose for the line B, we are measuring this degree because the north is very far from this point, south is very near, so we are measuring this degree. But here we indicate like that south, suppose it is a 15 degree, then south 15 degree east. Same way for the angle C. Here also the south pole is nearer, so we indicate the south angle to west. From south to west angle is this much because it is in a third quadrant. And in the if it is in a fourth quadrant, then the north is very near to line D, so we measure the angle alpha this. So north, alpha, west. So in quadrilateral bearing, it is indicated north to east, north to west, or south to east, south to west. So it is mentioned clearly on the which quadrant it is the line is lying. Now this is the whole circle bearing system. The whole graduated ring on the compass which we are taking, it is graduated like this. And 1 degree, it is divided into the 2 parts, so our accuracy is 30 minutes. Now it is mentioned what is the quadratic bearing system. What is quadratic bearing system? In this system, the bearing of the survey line are measured with respect to north line or the south line, whichever is the nearest to the given survey line, either in a clockwise direction or in a anti-clockwise direction, because we are taking the reading in a quadrant. The bearing of the line, if it is falls in a first quadrant or the fourth quadrant, then we measure the angle with respect to north. Our first digit is a north toward the east or toward the south. If our line is lying in a second quadrant or the third quadrant, then we measure our angle with respect to south direction, south to east or south to the west, because the south pole is very near to our line. Now reduced bearing. What is reduced bearing? When the whole circle bearing of the line is converted into the quadrantal bearing, it is termed as the reduced bearing. Again, repeat these things. When the whole circle bearing of the line is converted into the quadrantal bearing, it is termed as the reduced bearing. Whole circle bearing is from 0 to 360 any. Suppose it is 175 or 275 or 45, or we can say 85 or 125. It is called the whole circle bearing. But the reduced bearing is always in between 0 to 90 degree. Reduced bearing cannot exceed more than 90 degree, because in which quadrant it is lying, that we have to mention properly, or it is designated in which quadrant it is lying. So the value will not exceed in any case more than 90 degree. That we have to understand. Now see this figure. This quadrant, first quadrant, that is northeast quadrant, it is given. Here southeast quadrant it is given, here southwest quadrant it is given, and here northwest quadrant it is given. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Here the line, suppose one line is given OA and the angle is 70 degree. So here the bearing, whole circle bearing, we can say it is a 70. But if it is a reduced bearing, then we have to say that it is a north 70 east. First figure indicate the reference line with whom we are measuring the angle. The second, after the numerical figure, indicate the direction in which we are measuring the angle. Suppose we put north 70 degree east. That means the 70 degree angle is toward the east. Same way, if our angle OB, suppose our reference line or the survey line is OB and angle is 35, then generally we are writing the angle south 35 east. So here the south, that means we indicate S first, written S first. That means angle is measured with reference to south line. The second digit, that is E, that means in the direction in which we are measuring. 35 degree we are measuring in east direction. Similarly, in the third quadrant, suppose the line is OC. OC is our survey line, and if we are measuring the angle of 55 degree, then that is west. That means south 55 west. That means south is a reference line. Toward the west, our reference line, our line of survey is 55 degree. Same way, if it is line is in a fourth quadrant and line is OD and the angle measuring is 30 degree, then we simply return north 30 degree west. That means from the north toward the west, the angle is 30 degree. So this is called as a reduced bearing. Here all the four quadrant it is given. All the four quadrant it is given. Now see in this figure, the maximum value, numerical value or angle value is 90. No angle is exceed 90 degree. So that you have to keep in your mind when you are writing a reduced bearing. In the whole circle bearing, you are getting the value, any value in between 0 to 360, but in the reduced bearing you will not get any value more than 90 degree. Now here one table is given for the conversion of whole circle bearing to reduced bearing. Whole circle bearing to reduced bearing. Suppose whole circle bearing is given to you, and if the whole circle bearing is from 0 to 90 degree, then reduced bearing, whatever the angle is there, the same angle you have to put in a reduced bearing. Only you have to mention the quadrant, that is the northeast. That is northeast. If your angle is from 0 to 90 degree. If your angle, whole circle bearing is from 90 to 180 degree, then to get the reduced bearing, you have to minus your 180 minus your whole circle bearing. Whatever the reading you are taking, suppose it is a 70 degree or suppose it is a 100 degree, suppose, because it is in a second quadrant, so it is more than, value is more than 90 degrees. Suppose it is 100, then you have to minus 180 minus 100. So whatever the figure you are getting, that you have to mention south degree then east. Suppose your whole circle bearing is from 180 to 270, that is lying in a third quadrant. Then to find out the reduced bearing, whatever the bearing, whole circle bearing, you have to minus 180 degree. Minus 180 degree. So again you have to mention your quadrant that whatever the value you are getting from W.C.B minus 180 degree, that you have to put in between this, that is south value, then west. So it will indicate that your angle is in third quadrant. Same way, if your angle is in between 270 to 360 degree, then to find out the reduced bearing, you have to subtract your reading from 360. So this is the equation, 360 minus whole circle bearing, and here it is a fourth quadrant, that means north toward the west. So angle you have to put simply over here. So it is clearly mentioned. So this table, it will provide the conversion from whole circle bearing to reduced bearing, and you have to use this formula. Again I am repeating, suppose it is 0 to 90 degree, whatever the value you have not to modify your value, simply same value you have to return only by using the quadrant. If it is in a second quadrant, then the value is subtract from 180 degree, and you have to mention your second quadrant, that is southeast. If the value is 180 to 270, in between 180 to 270, then whatever the reading you are converting, that is to be minus 180 degree, and mention the quadrant. If it is 270 to 360, then again 360 minus your whole circle bearing and mention the fourth quadrant. Similar way, because many times you have to convert your reading into whole circle bearing to reduced bearing, and many times you have to convert your reduced bearing to whole circle bearing. Now we have seen that to convert the whole circle bearing to reduced bearing. Now we will see that how you can convert your reduced bearing to whole circle bearing. Now if your reading is in first quadrant, that is the northeast quadrant, then whatever the reading is given, same reading you have to simply return. It will indicate the whole circle bearing, because your value is in between 0 to 90 degree. Suppose it is in a second quadrant, that is in a southeast direction, south toward the east, that is in a second quadrant. Then to find out the whole circle bearing from the reduced bearing, you have to 180 degree minus your reduced bearing value if you put, and whatever the answer you will be getting, it is in between 90 to 180 degree, and it is your whole circle bearing. It is your whole circle bearing. Similar way, if your reduced bearing is in southwest, that is in a third quadrant, then to find out whole circle bearing, you have to put your reduced bearing plus 180 degree. You have to add 180 degree over here to find out whole circle bearing. So your whole circle bearing is in between 180 and 270. Your value should be 180 and 270. Same way, suppose your reduced bearing is northwest. That means your reduced bearing is fall on a fourth quadrant, and you want to find out the whole circle bearing. Then to find out whole circle bearing, simply 360 minus your value you have to put over here, and your value comes in between 270 to 360. So you will clearly understand how we can convert reduced bearing to the whole circle bearing and whole circle bearing to the reduced bearing. It is important because in some places we are using the reduced bearing, in some places we are using whole circle bearing. Now fore bearing and back bearing. What is fore bearing and back bearing? Bearing means, what is meant by bearing? Bearing is nothing but the horizontal angle which we are taking with reference to line in a clockwise direction. Generally, we carry out the survey by traverse. That means we are creating the traverse by line A, B, C, D, like that. Suppose our direction of the progress of survey is A to B. And if we are taking the reading by putting the instrument over A and taking the reading over B, then whatever the reading we are getting, that is known as the fore bearing. That is known as the fore bearing. So in the direction of the progress of survey, if we are taking the reading, that is known as the fore bearing. But in the back direction, suppose our progress of the survey is A to B, from B to C, from C to D. And if we are taking the reading from B to C, that is in the progress of survey, then we can call as the fore bearing of line BC. Fore bearing of line BC. But the A is behind, and suppose we are taking the reading from B to A, that is in the reverse of AB, then we can say it is a back bearing. We can say it is a back bearing. So fore bearing is nothing but the horizontal angle taken with reference to meridian in the direction of the progress of survey, that is called as a fore bearing. And if we are taking in a reverse direction, then it is called as a back bearing of the line. Now here see the figure. So from A to B, if you are taking the reading, then it is a fore bearing. So this angle with reference to north direction, A to B, that is called as a fore bearing of line AB. But from B, we are taking angle A, so that is this angle. It will indicate the back bearing. So that is a fore bearing, direction of the progress of survey, and in the reverse direction we call as a back bearing. So here also you can take the fore bearing from B to A also, if it is a progress of survey. If you are going in the reverse direction, instead of A to B, if you are going from B to A, then for B to A is your fore bearing, and A to B your back bearing. So depend upon your progress of survey, in which direction you are carried out the survey. So that is called as a fore bearing and back bearing. So already I have explained all this thing. The bearing of the line measured in the forward direction along the progress of survey is known as the fore bearing. Now the main important thing, that difference between fore bearing and back bearing is always plus or minus 180 degree. Remember these things. This is very important, that difference of fore bearing and back bearing is plus or minus 180 degree. Figure may be the plus, figure may be the minus. The bearing of the line measured in the backward direction is known as the back bearing, as we have explained. So back bearing is equal to fore bearing plus or minus 180 degree. This equation, so you have a fore bearing with you, very easily you can find out the back bearing. Or if you have a back bearing with you and fore bearing is not available with you, then you easily by using this equation you can find out fore bearing line. Now plus sign is applied when the fore bearing is less than 180 degree. Remember, plus sign is applied when fore bearing is less than 180 degree. If the value is less than 180 degree, then use the plus sign. If value is more than 180 degree, use the minus sign. Suppose the fore bearing value is less than 180 degree, then use the plus sign to find out the back bearing. If this value of fore bearing is more than 180 degree, use the minus sign to find out the back bearing. So in the quadrantal bearing, that is the reduced bearing system, the fore bearing and back bearing are numerically equal, but the quadrants are in just in opposite direction. Here this equation which we are using, that is for find out in a whole circle bearing. From fore bearing to back bearing and from back bearing to fore bearing, to find out the value in a whole circle bearing system, we are using this system plus minus 180 degree. But suppose we have a bearing in a reduced bearing system, then we have not to change the value, we have to simply change the north direction. If it is north direction, then simply put the south direction. If it is a east direction, then west. If it is a west, then put the east. And if it is south, then simply put the north. The value remains same. So to find out the back bearing and fore bearing in a reduced system, numerical value doesn't change. Only you have to change the quadrant. For example, if the bearing of AB is north 60 degree east, if this is the reduced bearing which is given to you, and if you want to find out the back bearing, then simply instead of north, you have to put the south. Value is same, and instead of E, you have to put west. So naturally, directly you will be getting the fore bearing to back bearing and back bearing to fore bearing. It is very easy. It is very easy to calculate it, because you have to simply the one word, north to south or south to north, east to west and west to north. Now here one example it is given, that convert the following whole circle bearing into the reduced bearing. Now the all reading are given whole circle bearing, because here the no north or south it is indicated, and value is ranging from 0 to 360. The first figure is 49 degree, the second is the 240 degree, third one is the 130 degree, and the fourth is 335. If you look, this is in the first quadrant, this is in a third, this is in a second quadrant, and this is in a fourth quadrant. Here for this example, we have not to look about in the quadrant, but simply I am explaining that because this is a whole circle bearing, you have not to look about in which quadrant it is lying. Simply we have to convert whole circle bearing into reduced bearing. And how we can convert? We are, first of all, we have to draw the figure. So we are able to understand in which quadrant it is lying. Because it is a 49 degree, simply draw the north and south, east and west, and draw the 49 line like this. This is a 49 degree. So we are able to understand that this is in a first quadrant. Since the line fall in a first quadrant, therefore the nearest pole is north pole and is measured from north toward east 49. Therefore the reduced bearing is north 49. Whole circle bearing to reduced bearing. We have to convert the whole circle bearing to the reduced bearing. So we draw the figure 49, actual figure, and we are able to understand that it is fall in the first quadrant, and the nearest pole is the north pole. So our reduced bearing is, you have to put north 49 east. So this is our reduced bearing which are converted from 49 to this is our value. Now the second part, 240 degree. First of all, draw the figure. Actual, this is north, south, east and west. If we put the 240 degree, that line will become over here. This is the our line indicate. Now if you look this thing, then it is very near to the south. It is very near to the south. Now to convert the reduced bearing, because it will fall in the third quadrant, and the equation you know very well, to find out the reduced bearing, we have to put whole circle bearing minus 180 degree. Minus 180 degree. And our value of whole circle bearing is 240 degree. So 240 minus 180 degree, it is a 60. So 60 degree is a value. But in the reduced bearing, we have to put the direction also. We have to mention the direction. And here the south pole near. So south 60 degree, west. Toward the west 60 degree our line is lying. So it is a reduced bearing of 240 degree whole circle bearing. If the value of 240 in a whole circle bearing, in the reduced bearing is south 60 degree west. In same way, now if it is a 130 degree, so take the example in each and every quadrant, so you are able to understand how we can find out. Suppose your line is lying in a third quadrant. So it is 130 degree, 133 degree. Suppose it is given like this. Now see the figure. So it is 130 degree it is given. It is north, south, east and west. And 133 degree it is given like this. This is our line. This is our line. So here to find out this, the reduced bearing, our equation is 180 degree minus bearing. So 180 degree minus 130 degree, 33 degree, that is 47 degree is the answer. And here the south pole, our line is near the south pole. The first figure is the south 47 east. So in this way we convert 130 degree whole circle bearing into the reduced bearing. Value is south 47 degree east. This is the third example. Now the last example, that is the 335. If our whole circle bearing is 335 degree, now convert this 335 into the reduced bearing. Now actually draw the figure north, south, east and west. Always draw this figure. Without drawing, simply don't use this equation, because if you memorize, then there is a chances of making the mistake. But if you draw the figure, there is no chances of making the mistake, because everything is in front of you. Always put north, south, east in this direction and west in this direction. Put the value 335. So 335, if you draw, your line is like this. You are very able to understand that your reduced bearing is in between north and west. Now to find out the northwest, naturally you have to subtract from 360 degree. So 360 degree minus whole circle bearing, and value is 335. If you put over here, you will be getting the reduced bearing, that is north 25 west. So in this way you are able to find out from whole circle bearing to reduced bearing. Now convert the following whole circle bearing into reduced bearing. Again, this is the second example. Convert. It is very easy. Now you can able to understand. Now without drawing the figure also, 190 degree, it is more than 180 degree. So it is lying in a third quadrant. So naturally whole circle minus 180 degree. Simply you put this value. So you are getting the value of 10. And it is more than 180 degree. South pole is very nearer. So first figure is south, and toward the east, because the value is more than 180 degree, toward the west. So naturally the reduced bearing is south 10 degree west. Same way 260. Again it is in the third quadrant. So the reduced bearing, that is the whole circle bearing minus 180 degree. The whole circle bearing is 260 minus 180 degree, and it is in third quadrant. So in the third quadrant we put the south figure first, then the angle toward the west. So south 80 degree west. This is our reduced bearing. Now 315. This is in the fourth quadrant. So whenever this figure whole circle bearing in the fourth quadrant, we have to subtract from 360. So to find out the reduced bearing, 360 minus whole circle bearing, we put 360 minus 315. So you are getting the 45 degree. Now here also the fourth quadrant, we have to put the first figure is a north, because the north pole is very near to our line. So we put the north 45 toward the west. This indicates that north 45 toward the west. Likewise. Now convert the following reduced bearing into the whole circle. The way in which we convert the whole circle bearing into the reduced bearing, same way we have to convert the reduced bearing to whole circle bearing. Now we have to convert all this in both way. We have to interchange our reading. So here it is one example. It is given some reduced bearing is given, and we have to convert our reduced bearing into the whole circle bearing. Now the first figure, it is given north 65 east. Now see this. This is in the first quadrant. This is in the first quadrant. The second, that the south 43 degree 15. That is in the second quadrant. So it is a second quadrant. So we are taking the example in all the four quadrants, so it doesn't have any confusion afterward. So see the example. Here the south 52 west. So this is in a third quadrant, and this is in a fourth quadrant. So here the first quadrant, second quadrant, third quadrant, and fourth quadrant, all the quadrant which we cover. Now let us northeast, that is the first quadrant, 6. So we doesn't require to put in whatever the reduced bearing it is given. Simply we have to put the figure. We will get whole circle bearing. So 65 is our answer. But for the second quadrant, that is 43 and 15 south to this. So we have to subtract from 180 degree. 180 degree minus whatever the angle of reduced bearing which is given to us, and the value we are getting it is 180 minus 43 degree 15 minute. So answer is 136 degree 45 minute. So this figure is nothing but the whole circle bearing. From reduced bearing is south east, and the whole circle bearing is 136 degree 45 minute is a whole circle bearing. Our third example, which is lie in the southwest quadrant. Now the reading which is given is 52 degree and 30 minute. Now to find out the whole circle bearing, what we have to do? We have to subtract 180 degree. So whatever the reading which is given minus 180 degree, so we are getting this thing. So our angle is 52 southwest. So we have to simply add. This is wrong, something is wrong over here. So 180 degree plus the angle which is given. So we add this thing. So we are getting this is the whole circle bearing. This is something wrong. Don't consider it is. And this is the fourth example. So it is in a fourth quadrant. That is north to west. So here to find out 360 minus angle. So 360 minus 32 degree and 42 minute. If we subtract this, the whatever the value we are getting, it is indicate whole circle bearing. Now see some different exam. The following 4 bearing were observed for the line AB, BC, CD, DE, EF and FG respectively. Determine their back bearing. Determine that back bearing. What is back bearing and fore bearing? Again I repeat, the fore bearing is nothing but the angle which taken in the direction of the progress of survey, and back bearing is the angle which taken in a reverse direction. Suppose A to B is the fore bearing, then B to A suppose we are taking, then it is a back bearing. And we know that the difference between fore bearing and back bearing is 180 degree. So if we have a fore bearing, then to find out the back bearing, it is a very easy thing. Simply you have to add 180 degree or you have to subtract. If your reading of fore bearing or back bearing is pretty less than 180 degree, then simply you have to add 180 degree, and if it is more than 180 degree, then simply you have to subtract 180 degree. Only you have to see that your reading is less than 180 degree or more than 180 degree. See the example. Now here it is given 148 degree angle and you have to find out back bearing. The value is less than 180 degree, 65. Again it is a less than 180 degree. Third one, 285. Again it is a more than 180 degree. Here also 215, it is more than 180 degree. This 4 reading which is given a whole circle bearing, and you have to convert from fore bearing to back bearing. And last 2 reading, it is in a quadrantal system, or we can say it is a reduced bearing, and you have to convert the this reading to the back bearing. So one by one we are taking. Number 1. Here whatever I have explained, it is given that if your reading is less than 180 degrees, simply add, or and vice versa. So plus 180 degree is used if it is less than 180 degree, and minus 180 degree if your reading is more than 180 degree. Now our first reading is 145, it is less than 180 degree, so simply add 180 degree, so you are getting 325 figure, which is a back bearing of line AB. Same way for the line BC, the value given is 65, it is less than 180 degree, so you have to add 180 degree to getting the back bearing of the line, and you are getting the answer is 245. Same way for the line CD, the value is given 285 and the value is more than 180 degree, and to convert into the fore bearing to back bearing, here you have to minus 180 degree because this value is more than 180 degree. So if you subtract 180 degree, the answer is 105, it is a back bearing of CD. And the last one for the line DE, the value is given 215, again it is more than 180 degree, so you have to subtract 180 degree, the answer is 35 degree. So all these are the nothing but the back bearing of line AB, BC, CD and DE. Here the bearing which is given is the whole circle bearing. The last 2, let us see the last 2 also, that line EF and FG. Here the bearing is given a reduced bearing. Here the bearing is given in a reduced bearing form, and the reduced bearing form we know that here it is a mention that south 30 degree east, that means it is in a second quadrant. Here for the line FG, it is mentioned north 40 degree west, that means in a fourth quadrant, it is in a fourth quadrant. Now whenever the reduced bearing is given to convert is very easy, that simply put south to north or north to south, east to west or west to east. Simply you have to replace your word. If it is south, then simply put north. If it is north, then put a south. If it is east, then put a west. West, then east. The angle you have not to change. Angle you have to not to change. Automatically it will convert from second to fourth and fourth to second. First to third and third to fourth. It is convert from this one. So here the fore bearing of the following line are given. Find the back bearing of the line. Again this is the second example. Now see that the line AB, it is given 310 degree 30 minute. Here BC, the bearing is given 145 degree 15 minute. Fore bearing of the line CD to 10 degree and 30 minute. Fore bearing of the line DE 60 degree and 45 minute. Now see that back bearing of the line. This value 310 degree 30 minute, it is more than 180 degree. To convert into the back bearing, we have to subtract 180 degree from this figure. So 310 degree 30 minute minus 180 degree and 0 minute is equal to, answer is 130 degree and 30 minute. This is the back bearing of line AB. Similar way, the second one 145 degree 15 minute. Again see, this is the value is less than 180 degree. So to find out the back bearing, we have to add 180 degree. So if you add 180 degree, the answer is 325 and 15 minute. Similar way, for the line CD, the value is more than 180 degree. So we have to subtract 180 degree. 210 degree 30 minute minus 180 degree is equal to 30 degree and 30 minute. Same way for the line DE, the value is given 60 degree 45 minute. It is again less than 180 degree. See here, it is less than 180 degree, even less than 90. But we have to see only the figure 180. If it is less than 180 degree, add 180 degree. If it is more than 180 degree, simply subtract 180 degree to find out the back bearing. So 60 degree 45 minute plus 180 degree, the answer is 240 degree 45 minute. Now fore bearing of the following line are given, find the back bearing. Again, this is the example of reduced bearing. The whole circle, previous example is the conversion of fore bearing to back bearing if the whole circle bearing is given. Now this example is the data given in a reduced bearing form, and you have to convert the fore bearing to back bearing and back bearing to fore bearing. So here the line AB, fore bearing of the line AB is south 30 degree and 30 minute east. Fore bearing of line BC is north 40 degree 30 minute west. Fore bearing of line CD is south 60 degree 15 minute west, and fore bearing of line DE north 45 degree 30 minute east. And you have to convert the fore bearing into back bearing. It's very easy. You see, this is, see, simply whenever you find south, simply put north, and whenever you found north, simply put south. Whenever you find east, simply put west, and whenever you find west, simply put east. It will convert automatically from fore bearing to back bearing and back bearing to fore bearing. Value, you have not to touch the value. Simply the direction you have to change. And the fore bearing to back bearing, back bearing. If you draw the figure, then you will be really understand that how it is converted. This is not a theoretical. This is not a part that you have to remember. Only once you draw the figure, automatically that line, how you are converting, that you are able to understand. So see, this is figure. Just see, first example, south 30 degree 30 minute east. Then answer is north 30 degree 30 minute west. Here for BC, north 40 degree 30 minute west. Answer is south 40 degree 30 minute east. Here the south 60 degree 15 minute west. Our answer is north 60 degree 15 minute east. And from north 45 degree 30 minute east, then answer is south 45 minute 30 degree west. So you are able to understand how you can convert fore bearing into back bearing or back bearing into fore bearing. Similar way, if you have given a fore bearing, you can convert the back bearing. If you are given the back bearing, then you can convert the fore bearing. It's very easy. Very easy. Now, using these things, you are able to find out interior angle, because our basic aim is to find out the angle between two lines. We are not interested to find out the fore bearing or back bearing, whole circle bearing or reduced bearing. Our basic aim is to find out the angle between two lines. But we are using this principle, or the knowledge of these things we are using to find out the interior angle. Now, generally interior angle, it is very easy to find out the fore bearing and back bearing. It is given, or it is a reduced bearing in the form of it is given. If you understand the example, then and then you are able to find out calculation. But the one thing is must, you have to first draw the figure. So you have not to remember any formula. If you are remembering the formula, then there is a chances of making the mistakes. So whatever the bearing which is given to you, it is in a whole circle bearing system it is given to you, or in a reduced bearing it is given to you. First thing that you have to draw the figure, and you use that figure to find out the interior angle. Look at this example, then and then you are able to understand. Now the fore bearing of the line AB, BC, CD and DE are given. So here look, this is the first bearing AB, then 45 degree 30. So always put the north in upward direction. So this is the line north, south, east and west. 45 comes here. You are very able to understand. You have not to draw exactly the figure. Approximately everyone know that 45 comes in between this. So line AB draw over here. So put the point B over here. Again mark a north line over here, and here the bearing is given BC is equal to 30. Bearing given here 120 degree 15 minute. 120 degree, that means it is more than 90 degree. It is more than 90 degree. So it is come in the second quadrant. So the 120, this is the north. So 120 is approximately come over here, second quadrant. So you draw the line BC. Approximately any length you can draw. If it is not a closed traverse, then the last point is A. That you have to match. But here in this example it is not given. So simply put 120 degree 15 minute and the line BC is to be drawn. Again from the point C, draw the north line, north, south, east and west. Now see the fore bearing of CD. Fore bearing of the CD is 200 degree 30. That is more than 180 degree. So more than 180 degree, that means in a third quadrant. It is in a third quadrant. So draw the line CD approximately of 200 degree in a third quadrant of any length. So line CD is to be drawn. Now again mark the point D on paper. Again draw a north line, north, south, east and west. Then mark this distance DE. DE is 280 degree 45 minute or 245 minutes. So here you understand that this is in a fourth quadrant. So simply draw approximately a line DE in a fourth quadrant. So this your traverse is ready. So by using this, in the next lecture we understand how the interior angle is to be calculated. Avar. Thank you very much.